In my previous video, you might have noticed that there is a knob missing on my tripod, or you didn't notice it at all. Nevertheless, with FreeCAD and 3D printer, I decided to make a new knob for my tripod. And it won't be just a knob for this particular application. I will design a knob where you can put in some parameters and have any knob fitting any application you need. This is called parametric design, and first of all, let me sketch what I'm planning to do. The knob I will design will consist of the part where you grab it with your fingers, a shaft where you put a screw later on. And now let me draw the views from the top. You can see there is a number of wings of this nut and a side view where you can see the shaft and the insert in the shaft, the hole for a screw later on. I will define the outer diameter of the knob and the inner diameter, the part where which make the wings pronounced, the thickness of the knob, the shaft length, shaft depth, and a shaft outside and inside diameter. For this project, I'm using FreeCAD version 0.21. It's not the release candidate yet. It's not the official newest version, so there are still some problems within. Let's start with starting a new file. And I will switch to Spreadsheet workbench, and there I'll add a new spreadsheet named dimensions. In here I will define the dimensions that I just mentioned before, the number of wings, and for each value we can put the alias in a value, and also for parameters that have the dimension, we define the display unit. So I have put all the diameters in here, all the dimensions, and I will also define the golden ratio. If you know what golden ratio is, then I don't need to explain it, and for those who don't know, it's basically the division of a length where the shorter part divided by the longer part is the same as the longer part divided by the whole of the dimension of the length. I'll start with defining a sketch in the XY plane. And here I'm using the drawing geometry to define the outer diameter of the knob. I'll constrain the radius of this circle. And this is why we need to divide the diameter by 2, because we are constraining the radius, not the diameter. And for us, it's more natural to define the diameter of a ready-made knob. That's why the spreadsheet contains the diameter. Now I'm drawing 2 lines, and I constrain the angle between them, and this will be the 360 divided by the number of wings that we have. Because now I will draw 1 wing. I will connect them with arcs. I'm using polyline for this, and with the M key on the keyboard you can cycle through the different modes of drawing a polyline. Let's have 3 arcs, and the outside arcs of the wing, I'll constrain them as coincident with the outer circle. The smaller arc will be constrained by those 2 lines, where angle would be again the total angle of the wing we are drawing, multiplied by the golden ratio parameter. And the last thing we need to do is to have those arcs symmetrical. So this can be done by adding another drawing geometry in here. I came up with this formula to define what is the size of the arc in between, and those two arcs need to be equal to each other. Now the construction geometry changed color, so it means it's fully constrained, it will not move anywhere, and now we need to pad it to the height of the knob thickness defined in a spreadsheet. The next step is to apply the polar pattern to the detail we just drawn. We will multiply it along the z-axis, and the number of those elements will be number of wings. I'll just come back one step earlier and add a chamfer to the outside of the knob. And right now it is important to select all the details, all the parts that we want to apply the polar pattern to, in the order that they were created. So first we select pad and then chamfer. Now this polar pattern, we created the basic shape of the knob. We can choose refine to true to get rid of those lines showing which part the polar pattern was applied to. And now if we play with the parameter wing count, we can see that the whole detail, the whole part with this design, well, it changes as we apply the numbers here in a spreadsheet. Next thing is, as I mentioned before, this version of FreeCAD has some problems with the referencing of the edges and planes, so I will define the datum plane perpendicular to XY plane, and I will move it along the Z-axis, so it resides on the top of the knob. So the value of Z for this datum plane is the knob thickness. Now here I'm drawing another circle that will be padded as a shaft. I see that the outside diameter of the shaft was defined far too big. So let's make it slightly smaller. We just need to redraw it. It's okay like this. And we can hide the datum plane by pressing the spacebar on a selected feature. And now we pad it. Again, the length of padding is the shaft length. Same here. If we change the values in a spreadsheet, then they will be reflected in 3D drawing. I'm defining another datum plane which will be placed on the top of the shaft, which will be the foundation for a sketch that will make the hole in the shaft. You'll see in a moment. Again, the placing of the datum plane is the total height, which means the shaft length and the thickness of the knob. Now I'm drawing here a circle that is constrained to the shaft internal diameter, and I'm putting a hole with a length, or depth in this case, that is the same as the shaft depth. I'm adding chamfers, and the problem is that those chamfers are defined on the edges that were created as a result of certain features. And if I change the number of wings, then the references to the edges, they just get lost, and every time we change some value in the number of wings, those references for chamfers, they get lost. It's a known problem in this version of FreeCAD. Release candidate version has already solved it. Nevertheless, is there a better way to draw this knob, design this knob? Well, at least a couple of them. So let me show you another one that I came up. Let's start another body. We will hide this one. And again, we're starting with a sketch, but this time the sketch is drawn in XZ plane. And what I will draw here, using polyline again, at least I'm hoping to use a polyline, I will draw a cross section of half of the knob. So if you cut knob through and then draw half of it, you get something like this. Now we need to constrain those segments. So again, this is the knob thickness, and I'm drawing actually the part of the inside of the wings. So later on, well, here I'm constraining the radius of the shaft. I can also add chamfers already in here. And I forgot to draw them as lines, so they are arcs. I need to remove them and connect those segments with straight line. So we have chamfers. Well, chamfers are basically easier to print with 3D printer. What I also heard, when you try to make it in the CNC with aluminium, it's much easier to chamfer than to have a rounded edge or a fillet. It's basically cheaper to manufacture. That's why the chamfers. And the last part, I need to define the length of this segment, and I decided for a chamfer of 0.6 millimeter height. So the length must be multiplied by square root of 2. As you could see, you can just put a formula in the definition of the dimension. Now other dimensions in here, but the sketch is still not constrained because we need to define the height of the shaft right now. Same as other dimensions, no problem with this. The last thing to constrain is the diameter, and it's not the outside diameter of the knob, but it's slightly smaller with the outside diameter of the inside of the wings. And I came up with some formula which will basically, depending on how many wings there are, the less shallow the cutting in will be. And again, divided by 2 because we are defining radius. Now, this shape needs to be revolved along that axis, but only for the section of 360 degrees. That is, again, the same as the number of wings, and actually the half of it, because we can mirror the wings again. This is what I told you before. When we change something in the shape that was defined as the first one, we lose the references to the edges where the chamfer needs to sit, and we have problems. But I'll leave it for now. What I'm doing right now is I'm drawing the half of the wing, what I was telling you before. Let's switch to drawing geometry, not construction geometry, and this will be first of all, it will be coincident with the shape of the wing, of the revolved part, and the length would be the same as the outside diameter of the knob, the thing that we need to define. Now, let me draw 2 arcs that will be, as I told before, the shape of the wing, and I'm defining them as a tangent, and in this case perpendicular to the respective shapes. we need to constrain it somehow. I came up with an idea to make those arcs equal. Again, green, it's fully constrained, but we need the complete shape. So let me finish this shape just by drawing an arc and a straight line here. This part we can pad to the top. Again, the length of the padding is the thickness of the knob. Now what we have here is half of the wing. We can add the chamfers, of course. And if we now take this part, we need to again select all the sub parts. We mirror it along the X or YZ plane. We have the same shape as drawn in the first example. So now let's apply polar pattern to it, and we get an arrow. Well, known issue. Don't worry about it. If you want to do something like this, then you have to apply a multi-transform, which is a series of transforms. So as I showed you before, first we apply mirror transform, and then we add another transform, which is a polar transform along the base Z axis, and here the number of wings. And what we have here is the complete knob. Last thing that we can do here is change refine to true to get rid of some of the lines in a 3D view. Well, click somewhere, and you have it like this. The first version of knob is again broken because we changed the number of wings, but in here we can change it whatever, and it's already reflected here in the drawing. So definitely this way is much better, but I can already think about a couple of improvements to the first version of the knob. What we can add here is the definition of a chamfer. If we want to have the chamfer of 0.6, as I defined hardly using magic numbers in the drawing. But if you want to have it adjustable, so again parametric design, then you have to change those values to the one defined in a spreadsheet, and this is basically the only change we need to do in here. Now the length of references need to be adjusted, and changing the chamfer size. I thought that here using a refine takes a lot of resources of the PC, but it was something else, so we could leave the refine on true. It just takes a lot of time. Now this is what it looks like. So we need to print it. And printing, well, nothing special about it. Oh, but adhesion is still great. I'm very happy with this. Just using paper glue on a glass bed, and all the problems are solved. This is what the knob looks like when printed, and now let's press in the shaft that was on the tripod. I will use an all the railroad workers vise. I got it from my friend. Well, it was his father's. Well, thanks, bro. And pressing in, it's pretty straightforward, and straight is really emphasized here. I'm using a washer to make sure that the knob is not damaged by the grips of the vise, and at the same the nuts not to damage the thread. Yes, I could grab it a different way. Sorry for this, but you can still see pressing in happens as it should. It's really tight fit, but nothing broke down, so the dimensions were pretty good, pretty great. And this is what the finished product looks like. This is what it looks like on a tripod. Hope you liked it. If you have some comments, please leave them below, and don't forget to like and subscribe. helps me a lot, and it helps me to beat the YouTube algorithm. Thanks again.